Today we'll be learning about Charles' law, which is named after Jacques Charles, a French fella, not to be confused with Jack Charles, a born-again black fella, or worse, James Charles. So our objectives today are to 1. State Charles' law, 2. Sketch graphs of Charles' law, and 3. Apply Charles' law to solve problems. So Charles' law states that for a fixed mass of gas at constant pressure, the volume of the gas is directly proportional to the absolute temperature. So first off, let's look at our constant variables. There are 2 of them. What must stay the same are the mass of the gas and the pressure. So in other words, it has to be in a sealed container, and the pressure, the atmospheric pressure, has to stay the same outside of that container. Once those are set, then your manipulated variable is the temperature, and the volume is then the responding variable. So if you were to plot a graph, you would see that you would get a straight line graph that passes through the origin. Now, key thing is also to note that it is the absolute temperature, the temperature that is measured in Kelvin. Only when the temperature is measured in Kelvin will your graph pass through the origin and be a straight line. When the temperature is measured in degrees Celsius, then it will still be a straight line, but it will not pass through the origin of your graph. So now we will look at a couple of examples of calculating with Charles' law.
A hot air balloon has a volume of 2,800 meters cubed at 99 degrees Celsius. What is the volume if the air cools to 80 degrees Celsius? We'll write Charles' law in the before and after form. V1 over T1 equals V2 over T2. We substitute in what we know. Remember, we have to convert temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15. So now T1 equals 372.15 Kelvin, and T2 equals 353.15 Kelvin. 2,800 meters cubed divided by 372.15 Kelvin equals V2 over 353.15 Kelvin. Solve for V2. Multiply both sides by 353.15 Kelvin. 353.15 Kelvin times 2,800 meters cubed divided by 372.15 Kelvin equals V2. V2 equals 2,657 meters cubed. Here's another example. At 0 degrees Celsius, a gas occupies 22.4 liters. How hot must the gas be, in Celsius, to reach a volume of 25.0 liters? V1 over T1 equals V2 over T2. Remember, we have to convert temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15, so T1 equals 273.15 Kelvin. Substituting in what we know, 22.4 liters over 273.15 Kelvin equals 25.0 liters divided by T2. Solve for T2. I like to cross-multiply here. 22.4 liters times T2 equals 273.15 Kelvin times 25.0 liters. T2 equals 273.15 Kelvin times 25.0 liters divided by 22.4 liters. T2 equals 304.9 Kelvin. Convert to degrees Celsius. Celsius equals Kelvin minus 273.15. So T2 equals 31.7 degrees Celsius. There are other gas laws